So in this video, we're going to talk about assembly language, and we're going to focus at the questions I especially looked at in the last tutorial. So I feel like a lot of people get confused about what's really happening. So whenever we have the a square bracket and the letter, we're referring to an indexation of an array. Now, what's an array? Array has a name, and it is basically a list of elements. We have element number 5, element number 15, element number 77, etc. And the indexation of the elements starts at 0. So in the 0th position we have 5, first position we have 15, all the way up to 1, 2, 3, 4, 5, 6, 7, minus 1, 6. 6th position is, if I were to do it, and that should be a 9. Made a mistake. Yeah. So as you can see, each of them return a value. So that's how we access it. This is stored in a memory in the 0th location, etc., etc. But each element takes up 64 bits. This is generally specified at the beginning of the question. And consider this like in 2's complement. So it will have, it's number 5, it's going to have, counting from the right, 1, 0, 1, and then 61 zeros at the front. Anyways, and 1 byte is 8 bits long, so 64 bits. Each element takes up 8 bytes in the memory, and each location is made up of a number. That's how the computer or the CPU finds the element or the information in the list, the memory. So the base of the array is where you find the bottom of array A. So bottom of array A. So this is actually important, and that will be given in the question. So at the base we have the 0th element, that is at the bottom, like that's at the earliest thing. And to find the first element, you have to add 8 bytes to it, because it takes up 8 bytes in the memory. So the pattern you will see is that base is at base plus 0, and what the base is really is just a location, because like the memory is just a really long set of numbers, and you have to just go to the base. You add 0 to it, you find the first element. You add 8 to it, you actually find in index 1 element, and all the way, right? So you will see a pattern of incrementation of 8. So we can kind of rewrite this as 0 times 8, 1 times 8, 2 times 8, 3 times 8. And if you kind of understand this, then you will understand why we multiply by 8 the letter inside, or the address inside the square brackets. And yeah, as you can see, we can generalize it in terms of arrays and indexation. So it's 8 times the index plus the base will give you the address of AJ. And this is the idea behind it. So, question 1 on the tutorial sheet, you're given the following. You're told x17 is the base address of the array A. x4 is the variable I, which has the value. x5 has the value of J. x6 has the value of K. So we're going to focus on one thing at a time. So we're already given K stored in x6, but we want to find the value of AJ. So we're going to multiply J by 8, which is logical shift left x, is it 5? And we're going to store it in a temporary variable. So we're going to store it in x9. We're going to shift x5 3 times, which is the same as multiplying it by 8. because it's 2 to the power of 3, so you shift it 3 times to the left. So then, after shifting it to the left, we can what do we want to do? We want to find, okay, so we have this number. So we want to add the base to it, and the base is x17. So we're gonna add x17, x9. We're gonna store it in x9 again, x17, comma x9, and that is the address. So now we have went to the location. We want to get the value of AJ. The value is going to be with LDR, load register. We're gonna store it in a temporary register x10 from x9, address x9. So now x10 has the value of AJ. I should comment this out. So logical shift left multiply by 8. We add the base to j times 8. We get the data in a j. Cool. So now what we can do is we loaded it. So now we can actually add store it in x10. We add the value of x10 with k, which is x6. And this is basically aj plus k. And now all we want to do is store it in AI. So what I'm going to do is shift I left 3 times. So LSL, and I suppose we could use x9 again. We're gonna one moment, I export hashtag 3. It's I times 8. Add store it in x9 plus x17. Now you'll notice that we have the same base because it's actually 2 elements of the same array. So we're adding like some number whatever i's, some number whatever j, and some number j, and we store it in a different location. So that's why all of these are necessary. Again, we found the location of AI. And then what we can do is store the variable x10, comma, in x9. And that is question 1. So here we have stored it in the location I in array A, whatever this is. So if you look at question 4, you're given an if-else statement. And as I can see from the previous exam papers, the last page you're given kind of a list of all the functions like add, LSL, str, what else is there, branch, and conditional branching. So if you understand the logic behind it, you're given the functions. So for question 4, we are told that j is greater than k, but how can we compare? Well, what we can do is sub s, or compare. I'm gonna use sub s just because I prefer that over the other one. But basically, what sub s does, well, whatever j is, x3, x4. What's really happening here is we are subtracting subtracting k from j and triggering the flags. Now, if you guys remember in one of the labs we had the ALU, where we had on the left hand side the letter Z, the letter C, the letter N, and the letter V. And the C stood for carry, the Z stood for 0, N stood for negative, and O stood for, or V stood for overflow. And by triggering these flags, you can use conditional branching now. So if the logic, right? So if K is bigger than J, then it will trigger the negative flag. C and Z and V, right? Because, so you subtract something from greater than or equal to, and if K equals J, then it will trigger the Z flag. So now we could use conditional branching, such as B less BLT. If it is less than, then go to label 1. We're going to put label 1 here. And we're going to say that add, we want to assign J to H. So we're going to get the register of H, which is X5. And we're going to get the value of J, which is X3. And we're going to add 0 to it. And by adding 0 to it, I'm actually just moving it to that register. What happens? What happens if it is not less than? Well, then we want to do an else statement. So we'll make an else statement label 2. I should call it like this. If true, boom. Hopefully this makes more sense. So if it's else, then we assign K to H. So we'll do the same thing, except instead of X3, we're going to do X4. But what will go here? Jump here. We'll also execute this, so we don't want that. So we'll do a unconditional branching, so it must happen. Label skip. And the reason I'm doing this is to skip over label skip. And if it's true, then go here and jump over label else. Right? So let's suppose it's not true. Then I want to go to label else. So it will only jump here if my bad, greater than, if J is greater than K. So this will only get executed if J is greater than that. So this will not occur at all. So my jump is here, here, here. I hope it kind of makes sense. If you wanted to simplify it, you could do the opposite of this, which is less than or equal to. And that way you kind of get rid of this. And yeah, and you can get rid of one line, basically. I will show, actually I might show it now. So I am just gonna work my way backwards. So again, what's happening is we're gonna trigger the flags, and we're gonna do less than or equal to, which means do it if it's false. So if it's less than or equal to, which means K is bigger than J, then run the else statement. False. Otherwise, do that. So we got rid of one line by negating kind of this statement. also get rid of that. So this is how it kind of looks. We got rid of technically 2 lines. We got rid of this line and we got rid of, well, the label. So the next one, we have a for loop, which we want to kind of iterate through. Actually, I'm gonna leave it at that, and I'll do those 2 questions in the next video. If you have any questions, just let me know. Bye bye.